Hi everyone, my name is Thomas Kim. Today is March 9th, 2019. This is 22nd episode about C++ type function and modern C++ programming. In this episode, we will learn typical C++ standard library callback pattern. More specifically, we will learn how to use std_variant together with std_vector. In our previous episode, episode 21, we learned how to implement compile time loop. Compile time loop plays very important role in advanced template metaprogramming or in the implementation of advanced type functions. This session is based on my previous episode. Please double-click this link. From this episode, click this button, download our previous source code. Click this button, show in folder, double click, copy the folder, copy, paste it to your working directory. In your working directory, double click, copy the folder path, copy, right click your command prompt, right click, properties, start in folder, paste, click OK, start Visual Studio Code, go to file, open folder, paste the folder path, backslash, enter, select folder, control minus once again, click this folder, select this folder, right click, copy, click here once again, right click, paste. Then this folder will be created, right click, rename, callback. Rename the folder like this, and here right click, select the loop, right click, rename, callback, CPP. Double click callback, Control plus, Control B. We will remove this part like this. I removed all, and here stream C++ standard library callback pattern. NL, start your command prompt, dir cd 22 callback, cl at pch local pch cpp msbc local callback cpp. We should see this message, void motivation. We will call this function enum. We define size t like this. idx means index age, idx weight, idx name. We defined enumerators such as idx age, idx weight, idx name are compile time expressions or constant expression using item t, std, variant, int, double, std string. we defined a type item using container t std vector item t container t myVec. We can initialize 1, 2, 3.14 James, Sophia, 35 Goodman. So we defined a vector of variant. We can access each element of vector like this for auto e myVec switch e index. E is a type of variant. E index returns currently selected index of the variant. E index is a runtime variable. We can access using this enumerator case idx age stream. Stream is this stream class we defined here. Age, we can get element like this std get idx age e nl. Don't forget break here. Case idx weight stream weight std get idx weight e nl break. Case idx name stream name std get idx name e nl break. So this is typical way to access each element of this vector or variant. Now let's build and run. So we see the result like this. Age 1, age 2, integral type is regarded as age, and floating point type is regarded as weight, and the strings are regarded as name, and these are all processed this way. This is typical way we use std variant. This approach has a few drawbacks. First, this accessing mechanism is inside the loop and it is error prone. We are apt to make mistake in accessing each element, and also this does not scale well. I mean, in some other part of the code in the same function, for example, in some other part of the code in the same function, for example, we may need to access each element of the vector of the variant. In such case, we have to repeat the same switch statement. So it is error prone as well as unwieldy. I copy this function, copied, pasted here. I rename better approach. Here I will delete this part. We introduce a lambda like this, or process, or E, or we say B, or index. We need to capture stream class, stream instance. We cannot catch global stream. We cannot catch global object in the lambda capture clause. So, or this is reference stream, or NL. Okay, then we can capture like this, stream NL. I copy this part, cut, paste here. We don't need this, we don't have E. This is index. Simply this index is the argument here, and we don't need this. You say value. Like this. With this lambda, we can modify like this. Talk play fun. Process variant. The first element is variant, and the second element is lambda, like this. We modified like this. Don't forget semicolon here. Then we call this function better approach. Now we build and run. It works exactly the same. The primary benefits of this approach are we don't need to access to each element using std get index var syntax. Second, we can use the lambda multiple times in the different part of the code. Now I will explain how to implement this processVariant function. Please note that we learned about compile time loop in our previous session, episode 21. We learned how to implement compile time loop. Also, we need to know if constexpr. This if constexpr is introduced in C++ 17. So please watch this video as well by clicking this link. In this video, I explained how to use constexpr and if constexpr. Now I create a class template size t start index size t and index. Struct static loop st template variant type name callback type static void process variant constant variant type var callback type callback. If constexpr start index less than end index, please note that this start index and end index are coming from this template parameter here. If start index equals var index, else we are calling this function recursively like this: start index plus 1 end index. This is template function, so we might need keyword template process variant. We call this function recursively var. We have to forward this callback std forward callback type callback. We are calling recursively this variant function here. Callback, the first is value. Say when we process this is value, this parameter, so we can do like this: std get start index var, this is value, okay. Then here we pass start index auto index in the lambda clause, okay. I hope you understand this. Then it's done. Now we call this function like this here: template type name callback type name type name types void process variant std constant std variant types var callback type callback. We call this function index 0 size of types plus 1. I explained about plus 1 in our previous session. Then template, we call this function, I will copy the This is var. Then we call back. We forward callback like this. Then it's done. Now I copy this part of code. Better approach. I copied and paste it here. And I will rename it test process variant. Okay. Then I will call this function copied, paste, disable. Here we don't need this talkplay part because we implemented this function here. Okay, so I delete this. Now let's try it. See, 1, age 1, age 2, last name Goodman. So it works perfectly. This process variant and this compile time loop works perfectly. This compile time loop plays very important role in advanced template metaprogramming and advanced type function programming. So please familiarize yourself compile time loop. Using this approach, we can use not only variant but also tuple, also std any. This approach is very useful. In future sessions, we will use this function again and again. In future sessions, we will learn more advanced type functions and we will learn about type list. Please subscribe to my YouTube channel. Thank you for watching.